that was a function sine. For the second function, the function cosine, the approach is going to be almost the same, right? So we're going to do another table, but this time we'll have the same values for x, but the answers are going to be different. Here, for example, if the value of x is 0, then we need to find, like the last time will be cosine of 0. Again, using the unit circle, cosine of 0, this time is going to be 1. Pi over 4, when x is pi over 4, cosine of pi over 4, it's again square root of 2 over 2 by using the special triangles, approximately 0.71. When x is pi over 2, the cosine of pi over 2 is going to be 0, according to unit circle. When x is 3 pi over 4, then this time is going to be negative square root of 2 over 2. Why is that? Because if you remember, 3 pi over 4 is in quadrant number 2. And in quadrant number 2, the cosine is negative in the unit circle. The approximation is going to be negative 0.71. When the x is pi, then the cosine is going to be negative 1. When we have 5 pi over 4, since this angle is in quadrant number 3, the cosine is going to be negative also, so it's going to be negative square root of 2 over 2, approximately negative 0.71. When it's 3 pi over 2, then the cosine is going to be 0. It's a quadrantal angle, if you remember that, is on the bottom on the unit circle. When you have 7 pi over 4, now this angle is in quadrant number 4, where the cosine is positive. So the answer is going to be square root of 2 over 2, approximately 0.71. And when we had 2 pi, the end of the revolution, the cosine is going to be 1. Okay, so now we have, again, these values 1, 2, 3, 4, 5, 6, 7, 8, 9 that we're going to use to graph. So in this case, I'm going to use the same Cartesian plane as I did in the previous one, because the idea is to compare how the graph of cosine behaves with respect to the graph of sine. So we're going to use another color. I'm going to use blue this time by using the values. The first point, 0,1. So now the cosine is going to start at 0,1. It's going to start the maximum value. Then we have pi over 4, 0.71, which is the same as with the one with the sine, but that's okay. Then pi over 2, 0. This time is going to be here in the middle on the kilogram axis. 3 pi over 4 minus 0.71. Again, this is going to be approximately here, but in 3 pi over 4, which is here. Okay, then we have pi minus 1, which is going to be here. Then we have 5 pi over 4, which is going to be minus square root of 2 over 2 again, which is here. 3 pi over 2, 0, which is going to be here. 7 pi over 4, this time is 0.71 positive, so it's going to be all the way here. And the last one, 2 pi, is going to end at the maximum value, which is going to be here. Okay? So now we're going to join the points together to get the function, to get the graph of the function. So we have something like this, all the way here. Then you go up, all the way here. Okay? So the blue one is going to be the function cosine. I'm going to mark it for you so you can understand what happens. This is the function cosine, and the green one is the function sine. So the idea here is that you compare what is happening here. If you observe, the function cosine has a graph that is very similar to the one of the sine. The problem is that it starts at the top instead of the middle, unlike the sine. But if we were to continue, the shape will be exactly the same. But why is that? Well, because in this case we say that there's a phase change between one and the other. Okay? A phase change between the function sine and the function cosine. There is a reason for that, because if you remember from our previous class, we already solved cofunctions. Okay? That's an extra information, so we can explain that later. But observe that the graph is going to be almost the same. Now, what about the different elements? Here, let's see, these elements were for the function sine, but for the function cosine, they're going to be the same. Why? Because again, the amplitude, same explanation as with the cosine and with the sine. Here, the distance between the equilibrium axis and the maximum point, which in this case is exactly the same, is going to be 1. The period, again, one complete cycle. When the function starts in the cosine, the top ends at the top, so we have, again, a period of 2 pi. The domain, again, exactly the same, is going to be from all real numbers, negative infinity to positive infinity, and the range is going to be from -1 to 1, included because the points are included here. And that's it. Try to understand this thing because those ones are the basic functions for sine and cosine, but we're going to use this a lot when we start transforming them. We're going to start stretching, in a vertical shift, horizontal shift, etc. But we're going to see that in a posterior class.